Hi everyone, in this video we're going to learn about HTTP and JSON. This video covers a lot of topics and gets into a lot of details, so we better get started. So this is what we're going to learn today. We're going to learn today what is HTTP, and we're also going to learn how HTTP works, how is it structured, how can we read HTTP requests and response and understand them. We're also going to use a really powerful tool that we all have in our browsers, the network tab, which is similar to the console, but it's useful for reading HTTP requests. After HTTP, we're going to talk about JSON. We're going to read some example JSON files and understand how JSON works and why do we even need it. So let's get started with HTTP. What is HTTP? HTTP, you've probably seen this in a lot of places. In every URL that you're seeing online, there's always this small HTTP prefix to the website, and maybe some of you wondering, well, what does this HTTP stands for? So HTTP stands for Hypertext Transfer Protocol, and we use HTTP. It's a protocol to communicate to a remote server to get some information from it. It is a way, but it's not the only way. There are a lot of more ways to communicate with remote servers. HTTP is one that's really simple, very popular, and easy to use. And it is designed like this. It is designed to be very easy and very readable. So we can use it in a lot of applications. And it is very popular in almost every application that needs some sort of connection to network. Uses probably HTTP to do this. HTTP messages are sent over a TCP connection. It's a little bit advanced topic, TCP. We will not cover this TCP in this video. And maybe last interesting fact about HTTP, that it is stateless. So HTTP is designed around that when you exchange a message, you don't remember the previous messages. And every new exchange of message doesn't remember, and it starts from a clean plate. This URL, I got a lot of my slides and information from this URL from Mozilla Development Network, and once again, it's really awesome place to check out for documentation, and their HTTP overview is amazing. I really encourage you to check this out, and it covers most of my slides, but also a little bit more. It's really good resource in my opinion. HTTP, how does it work? HTTP works quite simply. We have a client and a server, and when I say client, I say that it can be also a browser and a mobile phone. It can be a watch or a game. It's basically any system that can just make network requests. So we have the client here. When the client wants to talk to the server on the right, it sends an HTTP request. The server receives the HTTP request, processes the HTTP request, and then he decides what response should he send back to the client, and he sends an HTTP response to the client with the result of the request. Was that successful? Did an error occurred? Maybe with some data. Depends, of course, on the request and on the server. And one important thing to remember about, take away from this, that the server should always return something. It should always return a response for every request, which means that every HTTP request and response, they're coming in pairs. HTTP request, you send an HTTP request, you get an HTTP response all the time. And if you don't, so something probably went wrong on the server side. Also, it's important to mention that the server can't just send an HTTP response out of the blue without any request. To get an HTTP response, you must first send a request to the server. Now we'll check out how does the HTTP structure looks like. We'll start with the request. This in the middle is a sample request, HTTP request that we can see. It might look a little bit scary and intimidating at first, but we'll now break it into parts. Once again, I remind you that the request is something that the client sends. In our case, the browser, for example. So this is a string, And it looks like this, and let's break it into a part. First, we have the method. This get is the method of the HTTP. Some other methods can be post, put, delete. It represents the action that we want to do. In this case, we just want to get something. The next, after the get, is the resource path. Is the path that we want to interact with. In this case, we just want to get the index HTML page. And this is why it's get, and then we specify what we want to get. Next, we specify the HTTP version. And underneath, we have something called headers. This is a list of, it can be multiple headers, that the HTTP headers represent a metadata about the request. It's additional information about the request that does not belong to the data itself. And we also have optional body in the request. In this case, in this example, it is empty because we're just sending a request to the server like, hey, please give us index HTML. In this case, it's empty, and that's fine, that's optional. So this is an HTTP request. This is what we send to the server. Now let's check out what the HTTP response looks like for this request. This is an HTTP response example that the server might send us. And let's break it again into a parts. It looks a little bit different, but there are also some similarities between HTTP request and response. And it's also important to understand the difference between those. First, we have here the HTTP version that the server returns us. This is the HTTP version he supports. And it usually doesn't have to bother you anymore too much. You probably won't even notice this. Next, the server will send you the status code of the response. And the status code represents what happened to the request. Was it successful? Was it an error? If there's error, maybe some kind of error. And in this case, it's 200. And 200 in HTTP, it means OK, which is the status message that we also got. And 200 OK, which means that everything is good. Your request has been received properly, and this is the appropriate response to your request. After that, we again have headers. They're a bit different from the request headers. Again, it's a metadata about the request. It describes the body, and you don't have to learn or know all the headers. There are really long list of the headers, so don't worry about this right now. After the headers, we have the body itself, which is the content of the response. In our example, because we requested the index.html page in the previous request, then it kind of makes sense that the response is the HTML file itself. So there, of course, we can see here only partially because it's very long. So this is the basic HTTP request and response. And I just want to show you an example how this looks like in the real world. It's much easier to see this. So we have here GitHub. And GitHub, if I go to the development tools, here you usually use console to interact with JavaScript and maybe debug and run some commands. But there is this really important network tab. The network tab is very useful of catching and checking out HTTP requests that happen on your browser in real time. Let's refresh the page and see what happens. When I refresh the page, you can see a long list of items. Every item here is an HTTP request that your browser made. And as you can see, it made in 1 second really long list of HTTP requests. And the first one is quite interesting because I do want to see the first one. The first one is the first initial HTTP request that we made to github.com. You can see here, when I click on the github.com, you can see more tabs. And one of the tabs is a preview, but it's not that interesting. I can go to headers, and here I can see exactly what we saw in the slides. So I can see general information about the request. I can see what's the URL. I can see the method, a get. I can see the status code that we got 200 OK. I can see also the remote address. And then I can see also the response headers. So this is the headers that GitHub returns us. Again, don't worry about the headers at the moment. You can also see the request headers. This is the headers that my browser, my Google Chrome, sent within the request to get the GitHub page. And the response itself. This is not the preview, this is the actual string response that we got from GitHub. And surprisingly, or not surprisingly, this is the whole HTML page of github.com. And in addition, you can also see what are all those other HTTP requests. So there are a bunch of images here. Once you get the HTML page, your browser might need to read some more images from somewhere, maybe JavaScript files, maybe CSS files, and all of these, to get those from the server, the browser needs to make another HTTP request to get those. And this is exactly what happens here. Exactly what happens is that we have here a bunch of images, and you can also filter out, by the way, here. We can also see, for example, I want to see only JavaScript. So there are some HTTP requests to get JavaScript files, CSS files, images. You can check the image, and once again, even the image, it returns a response headers and the request headers, just like before. And you can also see the preview. There's the Google logo, and the response itself, it's binary, so it will not show you the response itself because it's an image in this case. Let's check out another example. We'll clear this page, and in the github.com we have this registration form. Let's see what happens when I try to input an username. There we go. So I put my username, and it tells me that the username Stasel is not available. That is true because that's my actual GitHub username. When I go back to the network tab, I can see that my browser already made a bunch of requests. And the last one, maybe it made a few requests about the username. And actually, when you search for the username, it just checks if the username is available or not, but just by making HTTP requests. So you can see here, once again, we have here the request itself. This is the URL that the request is requesting, so something called sign up check. It's probably checking if the username is available or not available, which is cool. And this time the request method is post, it's not get. And the status code returns something, it's not 200, it's 422, unprocessable entity. Okay, this red, maybe it looks like an error. And then we have, once again, response headers and request headers. And then we also, because it's a post, we also send some information. We can see this is what my browser sent to GitHub. This is the body that was optional on the slide. Here in this case, this is exactly what the browser sent. In this case, it probably sent the username that they want to check if it's available or not. Let's check the response. And the response we got from here, apparently it's an HTML file. It's not a full HTML file, it's just a partial small file which says username is not available. This is the response that we got. And maybe a few suggestions I see. When I try to maybe add a digit here, it does another HTTP request, and this time the response is Stasel5 is available. And if I go to the headers tab, it's 200 OK, because now this name is available and the request succeeded. So you can see here we learned that even small operations on the browser, they can trigger a lot of HTTP requests, and they're everywhere. Images, scripts, files, and even small pieces of data. And this is an important concept to understand, and I really need to hope that you will get familiar with the network tab. It's a really powerful tool when you develop an application that uses HTTP, which you will do starting from this week. Let's go back to the slides. I want to talk a little bit about the HTTP methods that we saw at GitHub. We saw already two. We saw one get and we saw one post. So HTTP method, it uses to get information, to retrieve information from the server. For example, get index.html. I want to get the page. You can also get some images. Get image. You can also get some data. For example, get current temperature data from the server. All of these are get, and they don't come with a body, because what you want is just query for information. You don't send an actual body or information to the server. Another one is post. Post is usually to create a new resource. Doesn't necessarily goes by, it's not a really strong standard, so you can use post for whatever you want. It's just more like what you should use post for. Post is usually to create new resource. For example, you want to register. If you send a registration form with your email, your password, and your username, it will probably do a post request to send this. Put, HTTP put, is to update a resource, and you have to send the whole resource from the beginning. So if I want to update my information, I need to send like a full-blown list of the new information. And not just the new information, also the current one. So just all the information, and the server will just update the changes. And patch, unlike put, you can send only the changed information. It's not really important to fully understand the difference between put and patch right now. You'll see this in the future, but those are the two differences between put and patch in HTTP. In HTTP, there's also a delete method, which makes sense, deletes a resource. Let's talk about status codes. So before status codes, just want to mention about HTTP methods. The HTTP methods are something that the client sends. So the server doesn't send methods. The client sends method because the client needs to specify what do we need. What does the client need? Do I need to get something? Maybe do I need to post something or delete something? So this is a client part of the request. And after you send it, you get back a response with some status codes. Let's check some of the status codes. In HTTP, there are a few groups of status codes that the server may return us, and it's important for us to understand what's the difference and how to read them. The first group is 200s, and those we already saw, HTTP 200 OK. 200 means successful. It means that the response was processed successfully, and the request was valid, was processed successfully, and this response contains probably the correct answer to the request. The next group is the 300s. They are redirection messages. So if some image moved from one URL to another, or some website moved from one URL to another, you might get a 300 redirection message, which means, yeah, your website has been found, but it's in a different URL. Please go there. The 400s are errors, but those are client errors. It means that the request that the client sent was not completely valid. It can be due to many reasons. One of the reasons may be the information is incomplete. You want to register to a website, but you didn't specify an email. So you'll get a 400 and 400 something with maybe an error like you're missing an email. Another, maybe the most popular HTTP error is 404, not found. If you try to go to a URL that the server doesn't know that exists, you'll get an error, 404, cannot find. There are also also might be authentication errors. If you don't have access to a website, you will probably get a 401, unauthorized. And the last group is the 500s. It's a server error. Server error means that something went wrong on the server side. So the client is not fault. It's not the client's fault. And the client should maybe wait for a later time until the server will resolve the problems. And there are also 100 messages in HTTP. I don't want to get into those. Those are informational messages. They're not really, we don't use them a lot, and they're really under the hood that happens in the HTTP. So I will not include those in this in the next section. So let's deep dive in some popular HTTP status codes. For 200, like I said, we have successful responses. So everything went well, goes well. So you can get 200 okay. You can get 201, which means the object that you just sent has been created. You can also get 204. It's a popular response when you try to delete something, because when you delete something, the server can just say returns like 204, no content. It means like success, but I don't have anything to send you back. So just success. And 300, a few popular 300 ones is moved permanently if the URL is always moved. So maybe the browser can remember to go to the new URL next time. There is also 302 found. So it's also redirection, and it really helps the browser to redirect to the correct URL. Client errors, some popular client errors. Bad request, that means that something went wrong with the HTTP request. It wasn't valid, it wasn't correct. Or maybe 401, unauthorized, and 403, forbidden. Those are two HTTP status codes that relate to permissions and authentication. And of course, 404, the most popular one, not found. HTTP 500 errors. So those are server errors. And the most popular one is HTTP 500, internal server error. It means that something went wrong in the server side. Some error, I don't know, they couldn't get the data, they have bug in the code, they have like some sort of exception. There's also 502 and 503. Those are more related to the server tries to reach a different server, because it might happen, but that server couldn't respond in time. So there's a problem in communication there. This is also related to server, and the client still have to wait for the response, and it's not the client's fault. This is the biggest difference between the HTTP 400 errors and 500 errors, that the 500 errors, they are server errors and they're server's fault, and the 400 errors, they're client's errors, they're client's fault. And next one is a common list of HTTP headers. This is really, really small list of all possible headers. You can check the headers online. There are so many different headers, and you don't worry about those right now. They have a very different uses or meanings, and you don't need to worry about this. But those are 6 headers that I think they're really maybe important to know that they exist. And those are the following. So the first one is this one, the content type. When you get a response from the server, you will almost always get a content type. And content type means what kind of type is the body. Is this an image? Is this a video? Maybe is this a document? If it's a document, is it a CSS? Is it a Word document? Is it an HTML? And those can be used both on server and on client. When the client sends a file to the server, it's also very useful for the client to use the content type to hint the server what is this file is going to be about. The next one is content length, and this specifies the length of the body in bytes. You probably downloaded the file a few times, and when you click on download, you have this dialog. Or maybe it just starts downloading, and then you see that you are downloading 1 megabyte out of maybe 500 megabytes. And the way that the browser knows what's the total size of the download file is by reading this content length header. So the server tells the client in advance, hey, this is the body, and this is the size of the body that you're now getting. Sometimes in the large files, in a download file, you need to download the whole file, and only then you can get the size of it. You don't know how big is the body unless someone tells you. So this is a very useful header. And also cookies. Probably heard about cookies. Cookies are passed in HTTP requests and responses. And the client and the server exchange data with cookies and using HTTP. Next one is accept language. It's a really nice, it's really useful for the browser to send the supported language of the browser. So if your computer is configured to use maybe Netherlands in the default, the browser might send, instead of English US, it might send Netherlands as the favorite language. And the server might maybe send you already a translated HTML page to your language. And actually, that's what really happens with a lot of browsers when you go to the settings and change those. Another important header is authorization header. Authorization is used to send some credentials or maybe API tokens. And you're probably going to use this in the future. And the last one is user agent. User agent is a really long string that it looks something like this. This is my user agent. And this string represents the operating system and maybe the type of the browser. And the server might read it, might do something, maybe will specifically return the appropriate file for Windows users or for Mac users. Those are only those are 6 headers that I really wanted you to get familiar with. You don't have to understand the HTTP headers at this moment. It's not super important, but it's really good to know that they're there. So let's do a small recap. And this is a small exercise that I want you to do with me. So I want you just to pause the video when I ask the question, think about the answer, and then you can resume the video to hear my explanation. So here we have an HTTP message, and it's a real one that I just copy and pasted here. And I have a few questions. The first question is this a request or a response? Again, feel free to pause the video and right now and wait for a few seconds, think about this and continue. Yeah, and the answer for this question is this is a response HTTP. This is a response HTTP message. And the way I know this is there's no get or post, there's no method here. Usually in HTTP GET, an HTTP request, we here have in the beginning get and then URL or path. Here we don't have it. We have here the response format. You can also see the status code here, which we know that only the server returns as the status code. Which leads to the second question. So what is the status code? And is it maybe an extra question was it an error or not? And the answer for this question is 200. We can see here in the first line, the server responded with 200 OK, which means there was no error, and this response actually has some data. And next question is a bit tricky. What is the body type? What I mean, what's the body type? What should I expect to receive in the body here? Is it a video? Is it an HTML document? Is it a CSS file? And the hint is you can try to look at the headers. Maybe you can figure it out. All right, the answer is image. It's not just image, it's even PNG image. We can clearly see with the content type that this response contains an image. And this string is actually the data of the image itself. And last question, what is the size of the body? And the size is, according to the request, is 33,270 bytes. We can know this by reading the content length header. So we should expect that this is a response of an image that is about They're 33 kilobytes in size. So this is that was really small recap of HTTP. I hope that you understand the basic structure. You're going to use HTTP a lot in the future, and I think it's very important for you to understand the concepts of the structure, how HTTP works. Last topic on HTTP is about HTTPS. You probably heard about secure HTTP, or maybe this lock thingy, or now browsers do today, like push you like a green label with secure. They say like, yeah, this website is secure. So what is this all about? The S stands for secure, so it's HTTP secure. And it basically, what it does, it encrypts all the HTTP requests and responses in a way that only the client and the server can read them. It's very useful because if you send a password to the server to log in, you don't want someone in the middle to listen to the network to just read your password. And this solves a lot of issues that there were in HTTP. Yeah, and like I said, it works the same. It just uses SSL or TLS instead of TCP under the hood. And now in the recent days, it becomes more and more standard, and almost everyone uses this in production. In fact, the newer versions of HTTP require to use secure HTTP. So it's better get to know that there is this such thing. But also, you don't have to worry about this at the moment. It's useful when you want to really publish your website online. But for learning material, this is totally fine to just skip the HTTPS for now, because the requests and the responses are the same. It's just the encryption that happens under the hood in HTTPS. So we concluded the HTTP section of this video. We now go to skip to JSON. So JSON, a few words about JSON. In HTTP, as you saw, HTTP basically is a string. You send a string to the server, and this string contains all the headers, all the body, the methods, and you also get back a string with the status code, more headers, and some body as well. And sometimes we do want to send really complex objects. We want to send the pieces of data, for example, maybe a list of users. We want to send something that's complex, some structures. That string is really hard to represent it in just maybe a really simple structure. This is why JSON becomes. JSON is JavaScript object notation, and it's a way to format the data. So you have a complex data, you want to format it so it will be easier to read by other programs. It's also worth mentioning that JSON is not for JavaScript exclusively. It's used by Python, Java, every programming languages can support JSON. It's just a data format. Another data format that maybe you heard about is XML. It looks very similar to HTML, but it's also a different data format. And we're going to work with JSON a lot. It's very popular and it's very easy to use. And the basics are quite simple. JSON has six different types that you can combine together. The first type is a string. The second type is a number. Third type is a boolean, it can be true or false. The fourth type is null. Once again, there's no undefined or not a number, it's only null in JSON. The fifth type is array, and the array can be contained of any of the other 6 types in this list. So you can have array of booleans, you can have array of arrays, you can have array of strings. And the 6th type is an object. An object has a name, it has a multiple key and values, names and values. And once again, the value of the object can be any of the 6 other types that you see here in the list. Let me show a few examples. I think you'll understand better of JSON structure with some examples. So this is the first example. The example here is a JSON array of 4 strings. That's it. Let's check another example. This example is an object. And this object has 2 properties. The first one is name, which its value is Bob. And the second property called age, which is a number, and I know it's a number because there are no quotes here, and the value is 21. The third example is now a little bit more complicated, and it contains an object. Once again, I know that it contains an object because I can see the curly braces here. And this object has two properties. The one is students, and students itself, it's an array of strings. The value of students is an array of strings. So you can see here 4 strings. Then we have the comma here to separate because we finished with the students. And then we have another property in this object. It's called fruits. And it also has an array of 3 strings this time. So here we have object with 2 properties, and every property is an array of string. The next example is also JSON. It is an array because it starts with the square brackets, just like JavaScript array. So it's an array, which means it can have multiple items. And yes, you can see that there's this one big object. This is the first item. And the second item is this object. And the first item is it's an object with 2 properties, name and age. And the second object is also an object with 2 properties, name and age. Now let's try to combine everything together to one more complex example. Now it's becoming a little bit more complicated, but this JSON, I can already help you and hint you that it represents a course. And this course, this object is a course, and it has 4 properties. The first property is called course, and the value is JavaScript 3. The second property is week, and it's a number. The third property is a teacher, and this is an object. This is an object with name and age, just like before. And the fourth property in this whole big object is an array of two more objects. So it kind of makes sense from the contents that you can have students, a student array, because there are multiple students, and every student has a name and an age. This concludes the really basic example of the JSON. So as you can see, you can mix and match everything together. And the more you read it, the more you get familiar with it. But those are the basics. It's not super complex. You just need to get used to reading those notations and those curly brackets. It's very simple. It's very similar to what we have in JavaScript, and that's why it's being called JSON JavaScript object notation. But let's look a real example of JSON. I have this really interesting website I found. This website it's an API that returns public holidays for a bunch of countries. And it's really interesting and cool API. When I go to the API page here, I can see the URL. It has an example URL. Let's copy this. I want to create a new tab. There we go. Maybe I can even change it to get 2020. Maybe I want to get the holidays for the Netherlands. There we go. So this is a JSON. We actually got a JSON from this API. And what you can also do, one of the things you can do, you can go back to the network tab. In the network tab, you can see the request and the response like before. You can have a preview, and Google Chrome actually makes it much more easier to read all the objects. Another way, which I also prefer, is to download a really cool plugin called JSON Formatter. It's an add-on for Chrome. It's very popular. You can just add it. And after that, you can just refresh the page. And this add-on actually formats JSON objects really beautifully. You can still view the raw text. You can also see the parsed. So this URL we got. First, we need to see what we did get. Did we get an array or an object? And we get an array. And the reason, maybe I'll make it a little bit bigger. We got an array, because I see a square brackets at the beginning. And this is array of multiple items, and I see every item is an object. So it's an array of complex object. As you can see, there you go. So we have 9 items in the array, and we can open and see every object contains a date, which is a string. Don't get confused with JavaScript date. This is just a string. Has local name, has a bunch of strings, has a boolean. Is it fixed? Is it global? It has countries. It's currently null. I'm assuming that it can contain an array, maybe. And that's about it. So here we can see a real JSON, real example of JSON. And you're gonna need to sometimes read and understand the JSON that you get back in order to work with it with JavaScript. Let's go back to the slides. And let's recap what we learned today in this lecture. We learned a lot today. It was very information heavy, and you don't have to get everything about HTTP straight away. So don't worry about this. It's more important to get the JSON part and the JavaScript programming part in this case. But you can always go back to this video just to get a reminder about what is HTTP, how it works, and how to read the requests and the responses. So we learned today is how to read the HTTP. We learned that HTTP can be used to communicate with remote server, and to do some actions like getting information or updating information. We also read and understood how does HTTP works under the hood a little bit. How does the request and responses look like? They're very similar. Both requests and responses have header and optional body. The request has a method like get or post. The response sends you always a status code like 200 or 404. We learned today how we used the network tab in Google Chrome to check out all the incoming and outgoing HTTP traffics. You can then find what kind of HTTP requests and responses the browser sent. We can see the details, we can see the headers. We can also check the response itself. And it's a very useful tool to check out the HTTP traffic and to debug your application. And last but not least, we also learned about JSON, where do we use it, and how does the JSON looks like by some examples, and one real-world example from a real API. And you'll be using JSON a lot to transfer data from the client to the server and read back data from the server and parse it with JavaScript. So thank you for watching the video today. I hope you learned a lot about HTTP and JSON, and you'll get these skills useful in the future. Thanks for watching, and see you next time.